math. Okay, so this is week 4, Thursday for math 6 on ratios. So question number 1 says, it rained a lot one winter, so much that 32 inches of rain, so we're going to underline this, fell in 8 hours. So this is rain in inches, that's the first one, right? And then the other one is time in hours, right? What was the rate of rain in inches per hour? Well, what you do is you put rate of rain is going to be the rain in inches divided by time in hour. That's the rate, okay? How much did it rain? 240 inches of rain per hour. No, it's 32 inches in 8 hours. So how much rain did it rain? 32, right? Time for hours is 8. If you want per hour, that means 1 hour. You won't have to divide them. You don't times them. Do you see that? You need to make sense of that. Do you understand why it's divided? It's saying, how many hours does it squeeze into 32 inches of rain? 32 divided by 8 is 4 inches of rain per hour. That's your answer. And you'll have this video to watch later, but it's division, okay? Okay, number 2. So don't write anything down, just pay attention. A boat propeller spins 1,044 times in 3 minutes. So in 3 minutes, it spins 1,044 times. What is the rate in revolution per second? Okay, so do you see now this is different? This is in minute. You need to convert that to seconds. Do you see that? Okay, so it spins this many times in 3 minutes. So how much does it spin in per second? Well, let's first convert minute to second. 3 minutes equals how many seconds? That's what you need to do first. You know that 1 minute equals how many seconds? It equals 60 seconds, right? So 3 minutes, what do you do then? If it's 3 minutes, what do you do with the 60? 60, no, times 3. 1 minute equals 60 seconds. 2 minutes equals 60 plus 60 seconds, which is 120 seconds. Do you see that? 3 minutes is 60 plus 60 plus 60, which is 180 seconds. So 3 minutes equals 180 seconds. 3 minutes equals 180 seconds. So I want 1 second, so I take 1,044 divided by 3 minutes. This right here will give you the rate of revolution per minute. This is what it will give you. But the question is not asking for per minute. The question is asking for the rate of revolution per second. So you take 1044, instead of 3, you divide by 180, because 3 minutes equals 180 seconds. So on the side of this, 1044, 180, well, let's figure it out. 180 is about 200, okay? 200 times 5 gives me 1,000, right? So 180 is close to 200. So let's use that times it by 5, which is 0, 40, carry the 4, 900. So if I put 5, 180 times 5 is 900, which then gives me 144 left. So then I put a dot and a 0. 180, let's try times 6. 0, 48. Oh, I could do more than that. So let's try. It's gonna be 8. 180 times 8 is gonna be 1440. Subtract, you get 0. So rate of revolution per second is equal to 5.8. That is your answer right there, 5.8. Rate of revolution per second equals 5.8. And if you're not getting it right now, it's okay because you have this on a video, so you'll be able to see that. All right, let's go on to the next piece. So question number 3. A skydiver is falling at a speed of 176 feet per second. How far will he fall in 2 minutes? So you notice how this is in seconds. You gotta convert that to 2 minutes, okay? So 176 feet over 1 second. Do you see that? We want to convert this to feet, 2 minutes. So this is what I'm trying to find, is that question mark right there. Well, let's go ahead and try to figure this out. Now, you know that 1 minute equals 60 seconds, okay? I want to get rid of the second. So this right here is a ratio. This is a ratio, or like I should say it's a proportion. Because you need it to convert it in minutes, because you need 2 minutes. If I convert it to 1 minute, then I just need to double it to 2 minutes. I'm sorry you don't get that, but just hang on there. So this is a proportion. 1 minute is equal to 60 seconds. Okay? So if I want to get rid of the seconds, I'm going to put 60 seconds on top. We actually did this last year. Over 1 minute. So then what ends up happening, and the reason why you want this on top and bottom is so that we can cancel it. So the seconds cancel. Now I have whatever number that is going to be feet per minute. Okay? 176 times 60. If I go ahead and multiply that, it's going to give me 10,560 over 1 minute. So for 1 minute, it's be 10,560 feet. But he needs 2 minutes. Do you see that? So then what do? I just multiply it by 2 to double it. Okay? Times that 2 on the top, times that 2 on the bottom. And I can do that because you can multiply anything by the same number, top and bottom. So then when you do this, 1 times 2 is now 2 minute. 10,560 times 2 is going to give you 21,120 feet for 2 minutes. And that is the answer right here. So it asks you, a skydiver is falling on this. How far will you fall in 2 minutes? Your answer will be I'm going to go back and answer the questions. The skydiver will fall 21,120 feet in 2 minutes. You know he falls 10,560 feet in 1 minute, so you have to double that because it wants 2 minutes. And so you multiply the top by 2 as well. Next one. A space shuttle complete 1 Earth orbit at 25,300 90 miles in 1.4 hours. What is a shuttle's average speed? Shuttle's average speed is going to be the miles over, or I should say distance. Distance over time. Okay? Distance is measured in miles, not feet this time. Time is measured in hours. So then 25,390 miles divided by 1.4. So 25390 divided by 1.4. You move that over by 1, so you have an extra 0. So now you're going to be dividing 14 into this. 14 times 1 is 14. Subtract, you get 11. Bring down the 3. 14 times 8, do it on the side. Is 112. Remainder 1. Bring down the 3. Hold on 1 second. Okay. Bring down the 9. Or I'm sorry, hold on a second. Wait. This doesn't look that one. I'm doing something wrong. Wait. Oh, no. It's already brought down the 3. So I brought the 3 right there. So it's bringing down the 9. 14 times 1 is 14. Subtract it. And you get a 5. Bring down the 0. 14 times 3 is 42. Subtract it, you get an 8. Bring down the 0. I'm going to put it down over here. Okay, so you have a little bit more space. 80. You see that? 14 times 5 is 70. Subtract it, you get 10. 14 can't go into 10, so you put a decimal right there. You put a 0 there. But I do know that 14 times 7 is 98. Subtract it, you get a 2. You can put another 0 down. 14 times 1 is 14. Remainder 7. We can keep going on with this, but after 2 decimal places, we can just stop. Okay? So then, here's your answer. Whoops, not money. Jeez. 18,135.71. So if I'm answering this question right here, and when you answer the question, you go back to the very last part. What is a shuttle's average speed? You just say the shuttle's average speed is 18,135.71. And you're gonna do miles per hour. And that makes sense. And I know that makes sense because it's 25,000 for 1.4 miles. 1.4 is bigger than 1. So if I reduce it down to 1, this will be smaller than 25,000. 18,000 is pretty close to 25,000, but it's smaller. You know what I mean? So by common sense wise, that actually makes sense. Okay, number 5. Mr. Stork earns $630 for 30-hour work week. What is his rate of pay per hour? Rate of pay per hour means how much money does he get 1 hour? Okay, so you're gonna start with rate of pay is equal to total earned for 1 week divided by total hours worked. Total earned for 1 week, his earning is $630. He worked 30 hours a week. So you just divide this. So on the side, 630 divided by 30. 30 times 2 is 60. So when I subtract a 3, bring down 0 down. 30 times 1 is 30. So since the answer is 21, the way that you answer this question what is his rate of pay? You could say Mr. Smorks.
No, it's time to go upstairs.
Rate of pay.
You can go with the brothers.
Mr. Smorks' rate of pay per hour. And do you see how this is exactly the same as answering the actual question? Per hour. His rate of pay per hour is $21. So whatever he works 1 hour, it's gonna be $21. 2 hours will be 21 plus 21, so 42. And then you just keep adding $21 for each hour you work. The zebra and the hippo had a race. The hippo ran at average speed, 15 feet per second. Remember, speed is distance over time. So this one for the hippo, his speed is 15 feet. Feet is in distance for 1 second. That's time. The zebra, on the other hand, ran 132 feet in 6 seconds. So the zebra speed, remember distance over time, he ran 132 feet in 6 seconds. So it's not 1 second, it's 6 seconds. Do you see the difference? This little thing right there, that means per, which equal to 1 second. Or if it's per minute, it's 1 minute, okay? So it says, how far is each from starting line after 10 seconds? So this is an interesting question. So how far do they run after 10 seconds? Well, the hippo is running 15 feet 1 second. So if I want it in 10 seconds, how do I get from 1 to 10? What did I multiply here? 1 times what gives me 10? 1 times what gives me 10? Balance it on top. What's 15 times 10? Nope. 1 times 15 is 15. The 0 just brings it down. 150 feet per second. So this is the rate of the hippo. The zebra is 132 feet for every 6 seconds. Unfortunately, you can't go, oh, 6 times what gives me 10? Well, 6 times 2 is 12. Do you see that doesn't work? So then what you need to do is you need to convert this to feet per 1 second. So how do you do that? You just take 132 divided by 6, because that's going to be how many feet he ran for 1 second. 6 times 2 is 12. 6 times 2 is 12. Perfect. So in in 1 second, the zebra ran 22 feet. You see that? If he ran 22 feet in 1 second, what is he going to run in 10 seconds? You just take 22 times 10. And again, you do exactly the same thing. 1 times 22 is 22. Do you see the 1 0 there? You put it down. So in 10 seconds, he ran 220 feet, and that's a zebra. So this right here is the hippo. This right here is a zebra. So we need to go ahead and re-answer this question. And remember, I always ask you to look at the very back. It says, how far is each from starting line after 10 seconds? Well, there's two of them, right? The first one's the hippo ran 150 feet after 10 seconds. The zebra ran 220 feet after 10 seconds. And that's your answer. Okay. All right. So I think we got like one more question left. It has two parts. All right. Jessica checked her gas mileage and found that she had used 14 gallons to drive 392 miles. So 392 miles requires 14 gallons. How many miles does she get per gallon? So it's saying how many miles can she drive with 1 gallon? You know how sometimes when you look at the gas stations, they have like a price up there, right? It usually says like $4.39. What that means is it's going to charge you $4.39 to drive 1 gallon of gas. Some cars will drive fast or drive more distances. With a gallon of gas, like my Honda will go about like 32 miles. Dad's car is a little bit more heavy with the engine, so that will only go 28 miles a gallon. There's some really bad trucks out there, like those really big Ford trucks, that will only go 15 miles a gallon. Does that make sense? So she drove 392 miles, and it's saying so how many miles does she get per gallon? So this is how you work it. Miles per gallon equals total miles driven divided by total gallons. How many miles did she drive total? How many gallons she used? So on the side, 392 divided by 14. 14 times 2 is going to give me a 28. Subtract, you get 11. Bring down the 2. 14 times 8 gives me 32. 1 times is 8. 8 plus the 3 is 112. So your answer is 28. So what does that mean exactly? Go back to your question. Yeah, so how many miles does she get per gallon? You just put Jessica got 28 miles per gallon. Let's go back to the original question and answer it. Okay, how many gallons of gas will she need to drive from Reno to Disneyland, which is 504 miles, okay? 28 miles per gallon, right? She get 25 miles for 1 gallon of gas, right? This question is saying, if she drives 504 miles, right? How many gallons of gas does she need, right? Well, equal. Miles goes on top, 504 miles, right? What am I trying to find? X. What does X mean? X is the number of gallons of gas to drive 504 miles, right? So then we just simply cross multiply. You see the pink part right here? You see the yellow part right there? You got to cross multiply that. So 28x equals 1 times 504 divided by 28 on both sides. That part cancels. So on the side of the work, 504 divided by 28. And on the side 28, well, I'm going to put 1. 28 times 1 is 28. If I subtract it, I'm going to get a 22. 22 is too small, bring down the 4. Do you see that? Now I'm going to do a little bit of math and figure it out. So in this case, because it's asking you, see, you're not converting gallons or miles to feet or whatever, you know what I mean? Over here, let me go back. That's a really good question. Over here, where you are converting to feet over 1 second, do you see that? If you convert feet to 1 second, you will have to flip it around a little bit, okay? Or like, hold on, let me see, I'm gonna find the one that we did before. I don't remember which one we did that required that. Okay, I'll tell you what, here. Okay, so when you have, let's say, 1 feet over 1 minute, right? And the answer wants you to do inches per second. Do you see how feet had to be converted to inches, minute had to be converted to seconds, right? Okay. 1 feet over 1 minute times, and you're gonna multiply, okay, well, 1 feet also equals 12 inches. Do you see that? So I can cancel that, right? Do you see that? Okay, never mind, forget it. I'm not gonna go over that one. Let's just continue with this. You're not getting it, so I'm not gonna do this. 224. 28 times what gives me 224? 28, I can round that to 30. 30 times 7 is 210. 28 is smaller than that, so let's try 27 or 7 because that's close to 224. That's gonna give me a 56, 14, 196. I think I go 1 bigger, so let's try 28 times 8. 64, 16. Perfect. 224. So x equals, I'm sorry, 18. 18. So what does that 18 represent? The question says, how many gallons of gas would you need to drive from Reno to Disneyland? X is number of gallons of gas, right? So you would just say, Jessica drove 504 miles from Reno to Disneyland, and she needs 18 gallons of gas. You don't have to say and she needs, you could say which requires. You could say, well, yeah, as long as you have the right answer, it doesn't matter. But that's what it means, okay? And that's everything, okay? On a separate note, you asked about the conversions. Okay, let's say I have 2 feet over 3 minutes. Okay, let's say I ran, that sounds really bad, 2 feet over 3 minutes, right? If I wanted to convert that, how long would that be into inches over seconds, for example, right? I want to end up with inches on top, seconds on the bottom. Well, feet is 12 inches. 1 foot equals 12 inches. So feet is on top. I need the feet on the bottom, so I can cancel it. So you put 1 feet and the conversion is 12 inches. Do you see that? Feet cancels. Now I have inches. Do you see how the feet cancels? I don't know. Hold on, we're not done yet. Now I have minutes. Well, I don't want minutes. I want seconds. I know that 1 minute equals 60 seconds. Do you see how the minutes on the bottom? So when I do the conversion, I need to have minutes on top so I can cancel it. 1 minute equals 60 seconds. 1 minute equals 60 seconds. Well, guess what? Seconds on the bottom. That's good. Minute cancels. Okay. 2 times 21 or 12 times 1. That is equal to 24. What is the unit? Inches. Then you do the bottom. 3 times 1 times 60. 3 times 1 is 3. 3 times 60 is 180. What's a unit? Second. Do you see how now I have inches over second? So 2 feet over 3 minutes is equal to 24 inches over 180 seconds. You could reduce this, but you know, yeah. But I'm not sure if this is what you're talking about, but this is what you do. Okay. All right. That concludes everything. Let's end it right now. You can go ahead and watch this.